All right, so this next example, find an equation of the tangent line to the curve y equals 2x cubed at the point 216. We've kind of done these before, but we'll use the power rule that we looked at in the last video. And so the derivative 2x cubed. Now, in this case, this was new because we didn't have one with a coefficient in front in the last video. But I mean, now we're just going to multiply the original exponent by the coefficient. So 3 times 2 would be 6. And then we subtract 1 from the exponent. So, so the derivative is 6x squared. Now we need to find the slope at this point, 216. So we're going to plug in 2 for the x. And so the slope at when x equals 2 would be 24. And so now we're really just plugging those in. So plugging into the point slope form. So plug the 216. So we have y minus the y coordinate equals the slope times x minus the x coordinate. Then we can simplify that if we want. So y minus 16 is 24x minus 48, and then we'll bring the 16 over. And so we have 24x minus 32. And that is the slope of the tangent line at this point, 216. Okay. It's really those are not too difficult as long as you remember that the derivative is the slope at a particular point. So we have the sum rule and the difference rule. These, if you remember from when we did limits, if you had the limit of the sum of two functions, you can just find the limit of each part to that and then add them together, or subtract as the case may be. Same thing with the derivatives. So when we have a longer string of functions, added and subtracted together, we can just find the derivative of each term and go from there. So g prime of w. So we're just going to take the derivative of each of these separately. So the derivative of 12w to the fifth, bring the 5 down. So 5 times 12 is 60. Subtract 1 from the exponent. Bring the 3 down. 3 times negative 10 will be negative 30. Subtract 1 from the exponent. The derivative of a linear, so we could really look at these together if you want. Negative 6w plus 5, what's the slope? The slope of that is negative 6. But we could also look separately. Negative 6w, 1 is the exponent, so negative 1 times 6. We just have negative 6, and then subtract 1 from the exponent, so 1 minus 1 would be 0. So this would be like w to the 0, which of course is 1, so we don't need that. And then the derivative of a constant is always going to be 0. For the simple case, if the slope of it, if we just graph y equals 5, that is a horizontal line. Slope of a horizontal line is 0. So slope of the constant will always be 0. All right. So that makes those pretty easy. And then well, not the last thing, but here's an example. And I think we might have mentioned this concept in the last video, or the last section, where we have position and velocity and acceleration. So we have the equation of a moving object is given by that function. S is in centimeters, t is in seconds. Find the acceleration. So if we have s of t, that's going to be the position function. V of t is going to be the derivative of s, and then a of t is going to be the second derivative. It's going to be the derivative of the velocity or the second derivative of the position. So that's always the relationship between these two. So if we're looking for the acceleration, we really just need to take the derivative of this twice. So we need to find v, which will be the derivative of s. And so we'll just do this one kind of quickly. 6t squared minus 10t plus 3. And then to get the acceleration, we just need to take the derivative again. And so this is just another polynomial. So we're just doing the power rule again. So we have 12t minus 10. And then we want to find the acceleration after 2 seconds. So a of 2, so that'd be 12 times 2 minus 10, and that gives us 14. And so there's the acceleration. And then acceleration after 2 seconds would be 14 centimeters per second. Centimeters per second squared, I guess. All right. Find the points on the curve y equals x to the fourth minus 6x squared plus 4, where the tangent line is horizontal. So tangent line is horizontal means y prime equals 0. So let's take the derivative, and then we will set it equal to 0 and solve for x. So the derivative of this would be 4x cubed minus 12x. And so if we want to find where the tangent line is horizontal, we're just going to set this equal to 0, solve for x. So we'll go ahead and factor out actually we can factor out 4x. And then we're left with x squared minus 3. So we have 0 equals 4x, 0 equals x squared minus 3. So we have x equals 0 here, x equals plus or minus square root 3. And so we have all of those. And so if you graph this, I think I remember vaguely what this looks like. I want to say it looks something like that. And at least we can kind of get that idea because y-intercept is 4, so there you go. And then in behavior, so even degree, positive leading coefficient, so we know it's going up on the ends, and then what it does in the middle. Anyone's guess, but we do know that we have 3 places where the first derivative equals 0. So there would be the negative square root 3. There is x equals 0, and there is x equals positive square root 3. So that's the points on the graph we're looking at. So anytime you see where is the tangent line horizontal, that's what we're looking for. Where is the derivative equal to 0? All right, so we'll actually we'll just finish this. We'll look at the exponential function here. So derivative of the exponential function is just itself, and it's not for any exponential function, but in particular e to the x. The derivative of e to the x is going to be e to the x. So that's a pretty easy one to remember. So 2e to the x minus x. Let's find first and second derivatives. And the derivative of e to the x, just e to the x. So the derivative of 2 e to the x is 2 e to the x. And then minus the derivative of x, which would just be 1. And then second derivative of 2 e to the x is 2 e to the x. Derivative of negative 1 is just 0. So that is all for that one. And then last example here, what is the slope of the tangent line to the curve y equals e to the x when x equals 2? What point on the curve does the tangent line have a slope of 2? So the derivative of e to the x is e to the x, of course. And what is the slope of the tangent line when x equals 2? So the slope of the tangent line at 2 would just be e squared. At what point on the curve does the tangent line have a slope of 2? So let's set this equal to 2 and solve for x. And of course, we get x equals ln of 2. And so that would be that. Okay, so we'll get into more complicated exponential functions later, but for now, just the derivative of e to the x is e to the x. It's probably as simple as it gets as far as that goes.